Morning, everyone. I'm Jason Moore. It's a pleasure to see you. Thanks for coming. I run the Atari Projects website and the new Retro Projects website, and both are dedicated to fun, relatively short, usually less than an hour projects that you can do with your Atari or other retro computers. So if you have one and you want to expand your horizons and have fun with them, be sure and check them out. I'm an old school Atari guy. I started in the early 80s with Atari 400 and 800 home computers and have had a love for Atari and since then, and have a pretty extensive collection. I've also branched out into other systems. I do Commodore and Apple and Amiga, etc. And I moved a few years ago to Southern California from the East Coast, and it took 66 boxes to pack up my collection, and that was after thinning it out quite a bit. There's a lot of bubble wrap in there too, so it's not all hardware. I do a lot of things with the Atari. I also dipped my toes into programming. This is a game I made for the Atari 2600 in assembly language, which took me about 6 months to do. I don't recommend programming for the Atari 2600. You've been warned. So the motivation for this talk is that, as you know, these systems are now approaching 50 years old. The Apple II, of course, came out in 1977, and the Atari 2 years later in 1979. We're going to be having 50th anniversary parties for these systems in just a few years. For those of you that have big collections, these systems fail. As you can imagine, they're prone to failure. Nothing sadder, in my opinion, than a sad Mac. When you boot up a Mac and get the sad Mac face, that just troubles me every time. So I want to start with diagnosis. So you got a computer, it doesn't work. A couple of you have come up to me and said, look, I got this machine, it doesn't work. And there's nothing more frustrating than a retro computer that doesn't boot or boots to a black screen. And so the first step, of course, is to figure out what's wrong with this thing. And I actually like this process. It can be frustrating, but it's also a lot of fun to do the sleuth work, to get the clues, to figure out what's wrong with the machine. And the first thing I recommend doing is to check the voltages. And so you need a multimeter for that. So this is an Atari 800XL motherboard, which has 5 volts running to all the chips. So you can use the multimeter to probe around and make sure different parts of the circuit board are getting a nice, steady 5-volt signal. And if it's getting, less or more than that, that can be an indication that something's wrong, maybe with the power switch or one of the voltage regulators. And that can bring a computer down or even do damage if the voltage is too high. I highly recommend getting a newly made power supply for these old systems. Don't use the old power bricks. Many of them are problematic, and they can do a lot of damage to a circuit board. And there are a lot of newly made power supplies for all the systems. The Atari is a nice simple one. It's just 5 volts, and those cost around 20 bucks. Commodore 64 has a couple different voltages, and those run about $70, $80, which I cringe every time I buy one of those. They're just too much, but they are recommended. Just to give you an example, this is a Commodore 64 board that I repaired recently. And this is the symptom. It had this wavy screen, and Commodore 64, by the way, C64, there's a lot of repair videos, and I do a lot of repairs of C64s because so many things go wrong with those machines. They are very unreliable. And so there's a pictorial fault guide at pictorial64.com that shows all the different crazy screen symptoms that can go wrong with the Commodore 64. So it's very helpful. So you can go to this web page, match it up to the screen that you're seeing, and it'll show what the common problems are. So I went to the pictorial fault guide, and it said this oscillator chip in the U31 socket here. This is the circuitry that creates the clock signal on the board. That oscillator chip was supposed to be bad. So I installed a socket, replaced the chip, and it did not fix it. And there were no other suggestions on the pictorial fault guide, of course. I was like, oh crap, what's wrong with this thing? So I started checking around. I figured something was wrong with the circuitry here. I tested the resistors and the capacitors and the other chips and couldn't find anything wrong. So I know there are a couple experts in the room. Can you see that? You can actually see what's wrong with this board. Can anybody see what's wrong? It took me a while to figure it out. I tinkered with this board for probably 2 weeks before I finally occurred to me what's wrong. No. All right, I'm going to tell you. This voltage regulator here is supposed to have a heat sink on it. And so what was happening was this board, actually when you first booted this thing cold, the screen looked fine, and after about a minute it would slowly get wavier and wavier until it looked like this. So what was happening is this voltage regulator was heating up, and when it got too hot, and actually if you touch it after it's been on for a while, it's like burning hot. You will burn your finger. And so that was creating this symptom. So it was a voltage problem with the voltage regulator. So the way I figured it out is I took a pair of pliers and I grabbed onto that voltage regulator. As soon as I did that, the screen went normal right away. So I installed a couple heat sinks on there and it fixed it right up. One of the nice things is people are creating diagnostic cartridges for a lot of these old systems. So the Commodore 64, for example, has something called a dead test. That will bypass a bunch of the main ICs and just use the video chip and the PLA and the CPU, and it will actually do a memory test and go through some of the tests. So it's a good way to start to diagnose what's wrong. It doesn't always work, but sometimes it can give you some important clues as to what's wrong. I have this running on my exhibit, the SysCheck 2 for the Atari. It does a nice RAM test. And I can tell you exactly which RAM chip is bad. And this is an Amiga 500 circuit board, and they have a diagnostic ROM. You can replace the Kickstart ROM in the Amiga with this Diag ROM and get some clues as to what's wrong. So I would, if you have a board, this is something you can do. Invest in one of these these testers, and that can often point to what's wrong. The diagnostic cartridge, the dead test for the Commodore 64, I think you can get those for $30, $40, $50 on eBay or elsewhere. Another good thing to do is check for hot chips. Often a chip will actually short and create voltage where it's not supposed to be, and that constant voltage can up the temperature of the chip. And so one of the first things I do is touch all the chips. And sometimes the chips actually are burning hot when they're shorted out, and that can be a quick test to find which chip is bad. Some people use a thermal tester or an infrared heat. I don't have these things, but you can buy these and use it to scan your board if you don't want to burn your fingers. I personally like to burn my finger, and that's the way I do it. Chip testers are also useful. This is my TL8662 programmer. I bought this originally to program EEPROM chips, so I can make my own ROMs, et cetera, to put in the systems, or make my own cartridges, game cartridges, which I've done. But the newer versions, mine's about 6, 7 years old, but the newer versions of this that you can buy, and they're not that expensive. I think they're less than $100. The newest versions can test 30,000 different chips, and so you just pop it in there, you choose which chip you want to test, and it'll run the logic, the signals through, and it knows what the output's supposed to be and can tell you if the chip's bad. It won't test RAM, and it won't test some of the custom ICs, like the video chips and things like that. But for all the logic chips and the multiplexers and stuff that are on a lot of these boards, you can just pop them in, and in a few seconds you know if it's good or bad. This is actually a screenshot of a logic chip that I tested in a disk drive that was not working. Getting to know circuit diagrams is really important for troubleshooting, diagnosing computers. This is from Zimmers.net, which is a source of circuit diagrams for the Commodore 64. And so that allows you to look and see how the chips are connected, where what's connected to what, and I'll talk about using an oscilloscope in a few minutes, but this is really useful for probing with an oscilloscope or a multimeter to see what's wrong with the chips. It's a little tedious, but can be very informative. And one of the things you can do is what's called continuity testing. So the light green circuit traces here, sometimes those get damaged, especially if you've inherited a computer that somebody else has worked on or installed sockets on or something. Sometimes those traces get damaged, or the contacts where the pins go into the board get damaged and can remove functionality from a particular chip or a particular line on the board. And so continuity testing is you can use a multimeter, as I'll show in a second, to look and make sure different parts of the circuit board are talking to each other. And this is a board that I did some troubleshooting on. I had actually installed lots of sockets on this board. I was kind of developing this as a test board for Commodore 64 to be able to swap chips in and out. And after I finished doing all the sockets and repair work, it stopped working. After a while of hemming and hawing about this board and testing different things, I sort of came to the conclusion, all right, I must have damaged something on this board. So I had to do continuity testing to figure out where the trace was that I had damaged. Fortunately for this particular board, this 250407 Commodore 64 board, somebody's recreated the circuit board. You can buy these new. And they, on their GitHub, they have this interactive diagram where you can, with a mouse, you can click on any pin and it highlights in red all the places on the circuit board where that pin goes to. So what I did with this board, I started going pin by pin and doing continuity testing with my multimeter shown here. This is it set on continuity mode here. And so you can touch on a pin and go to another pin that's supposed to have continuity and get a beep if they're connected. And so after I must have spent an hour or two doing this, I found out this pin right here on this 74LS373 latch logic board chip. This was supposed to connect to the ground plane, and it was not connecting to the ground plane. So I had clearly, when I removed the chip and installed the socket, must have damaged the top side of this board. Unfortunately, I installed the socket on top of it, so I would have had to remove the socket to inspect the damage. So what I did was, fortunately, there was a via, a solder hole here in the middle of the ground plane, and I was able to just put a solder blob on here to connect that pin to the ground plane, and that fixed the computer, and it booted right up. All right, so now an oscilloscope is a very useful tool. I highly recommend, if you do a lot of this kind of stuff, I highly recommend an oscilloscope. It's been incredibly useful. I've been able to diagnose and fix a number of computers using the oscilloscope, and it would have been much harder without it. This is the one I have. It's in my exhibit out in the hall. This is a Siglent. I paid for $500 for it. I actually bought this at Micro Center, which is just down the road. And if you don't know, there is a Micro Center nearby. Don't go there till after the show. Make sure you have a couple hours and extra room in your suitcase. So I bought this oscilloscope, and it's a 4-channel. So I have this set up on my exhibit with the 4 channels running. The more channels there are, the more expensive these are. So this is 100 megahertz, and the higher frequency that it can measure, the more expensive they are. You can get a 2-channel 50 megahertz one for maybe $300 or $250, so just depends how fancy you want to get. But there are cheaper handheld models that are less than $100, and I don't have one of these, but I've watched YouTube videos of people that have reviewed these, and they seem to do an okay job. So if you can't, $500 is a lot of money to drop on one of these things. But you might be able to get one for $80 that gets you most of the way there, and for what you're doing might be perfect. So learning how to probe around a board using an oscilloscope, important thing is to learn what the different pins on the chips do. And fortunately, you can, for any chip on any of these common old computers, you can look up what's called the pinout, which is a map of the pins on the chip and a description of what each one does. This is a fancy one I found for somebody made for the 6502, the Sally chip in the Atari. And so each chip has a different function and a different reading that you can get familiar with. So there's the pinout for the Atari 800XL 6502. And so for example, wherever you see a line above one of the descriptors, that means that voltage is supposed to be high. So on the Atari, the signals on the circuit board run between 0 and 5 volts. So that's all the chips are supposed to be oscillating between 0 and 5 volts. Sometimes they're low, sometimes they're high, sometimes they oscillate back and forth. So the key is to know what to expect. What are the signals supposed to look like? And when you're probing around looking for problems, you're looking for deviations from that. Like if when you turn the computer on, there's one of these pins is the reset pin. It starts out low. When you turn on the computer, after about a second, it goes high and it stays high. And so you can put your oscilloscope on that pin, and watch that happen, and if it doesn't happen, you know something's wrong. So that's the basic idea here. Here's pin 39's the clock signal, so that's the cadence of the computer, so that oscillates on the Atari at 1.79 megahertz. And so you can probe pin 39 and watch the signal, and so if that doesn't look right, you know there's a problem with the oscillator circuit. This is the data bus that's sending bits of data out to other chips or the RAM. This is the address bus that's sending the address to where the bits are supposed to go in the RAM. This is the read-write, so you can see pin 36 over there. The W has a line over it. That means this is normally high, and it's writing data out when it's high, and when it drops low, it's reading data from somewhere else, pulling that into the chip. And so you can just look at these signals and make sure they kind of look like what you expect. I have a little video here. Let's see if this will play. It's just showing you the data bus in action on this Atari. So you can see it just kind of oscillates up and down. And if you're getting a signal that doesn't go to 5 volts, let's say it goes to 2.5 volts and only goes halfway, then something's pulling that signal down. There's a conflict somewhere on the data bus. So those are the kinds of things you're looking for. This is a healthy signal because it's going up to 5 volts and dropping down. And this is the setup I have on my exhibit, using all 4 channels to probe those different pins of the 6502. So this is what you get with multiple channels. You can hook up multiple pins simultaneously and watch and make sure they're all kind of doing what they're supposed to be doing. You can see the yellow oscillator here in the background. Okay, so let's move on to repair. So you've diagnosed, maybe you have an idea what chips are bad or circuit's bad. What do you do? Well, you need repair tools, and I can't emphasize this enough. It's good to invest in good quality tools. You know, cutting yourself short just leads to more problems in my experience. So yes, some of these things are expensive. The oscilloscope is expensive, but I think it's well worth it. So this is, I pulled out all my tools and took a picture. This is what I usually use, and with a multimeter, soldering iron. The desoldering gun here in blue and the hot air rework station are really useful for removing chips from the board. I'll talk about that in a few minutes. 99% isopropyl alcohol is great for removing gunk and dirt from the boards. Contact cleaner is really useful for cleaning up the oxidation on chips, chip pullers, etc. And this gray mat here I invested in. So a lot of people use these blue silicone mats that everybody's seen, and that's what I was using. And then I watched a YouTube video of a guy that actually was measuring the static and was getting static through that blue silicone. And after I saw that, I thought, oh my God, I shouldn't be using this. And I noticed when I would pull my blue silicone mat off the desk, it would have static underneath. And that static can do a lot of damage to your circuit board. So this is a blue, one of these blue silicone things. So I got this gray mat. I got it from Weller. It's rated specifically for static, and I've never seen a bit of static from this thing. It's on my exhibit out there. You can take a look at it, and you can attach a wrist strap here to protect yourself against static discharge if you live in a place with a lot of static. So anyway, I love this gray mat. It's been fantastic. It's nice and big too, so it's a nice big work surface, and I've had no static issues with it. All right, so one of the things you might want to try first is, if you suspect a chip is bad or not working correctly, is reseat it, because the pins get oxidized and sometimes lose contact with the socket or the circuit board. And I fixed a Commodore 64 that I bought at a Commodore show a couple years ago in Burbank, and got it home. It was in beautiful condition. It looked brand new. Got it home, and the keyboard wasn't working, and the cursor wasn't flashing. And so I thought one of the CIA chip or something was bad. I did a lot of probing and testing, and turns out all I had to do was reseat the kernel ROM with some contact cleaner, and it fixed it right up and started working. So that's sometimes a fix is as simple as that, using some contact cleaner, reseating a chip. That's one of the first things I'll do, is go through and reseat all the chips with contact cleaner, just to make sure they're getting a good healthy signal. Removing bad chips. This particular Atari 800XL circuit board, notice that none of the chips are socketed. They're all soldered directly to the circuit board. Sometimes you get boards like this. And if you find a chip that's bad, the only recourse is to remove it from the board, which means desoldering, which takes a little practice and the right tools. So I use a Hakko FR301, which is very common. A lot of people use these. They're a couple $100, so they're not cheap, unfortunately. I also bought this one at Micro Center. That was a $1,000 shopping spree when I got that in my oscilloscope. So they're not cheap, but again, well worth the investment. Some of you came to my table and we talked about this, and you said, some people were saying, yeah, I got one of these and I never have regretted it. So it's well worth the investment. And the basic idea is it heats up. You can set the temperature on it, and you just put the end over the pin, and just move it around for about a second or two, and that melts the solder. And then you pull the trigger, and it sucks it right up into the chamber there, where it dries and makes a little ball. And you just have to clean that little cartridge pops out, and you just clean it out, dump the solder out. There's a little filter in there that you need to replace sometimes. And it's that simple, and they're very effective. You can see here, these are here's one that I haven't done yet, here's one that I did. Now, sometimes the solder, even though you've cleaned it out from under the board, sometimes there's residual solder on top of the board that you can't see, that's under the socket or under the chip. And if you try to lift the chip out with that solder stuck there, you can actually lift the traces on the board and damage it, which then you have to do repairs. So the popular method is to use a hot air rework station. This is my EHA. I bought this on Amazon for about $60. Fortunately, they're not that expensive. You can set the temperature and you can set the air flow control. And this one's really quiet. I love this model. I've been very happy with it. So the basic idea is you heat this up to about 600 or 700 degrees Fahrenheit and just slowly rotate it around the chip, and the hot air melts, not very long, maybe 5 seconds, it melts the solder. And then I apply very gently, just a little bit of pressure with a chip lifter or a screwdriver, and you just kind of wait for it to get loose, and then it'll pop right out. Now, again, a good desoldering iron and a hot air rework station are really important for getting chips out cleanly without damaging the circuit board. Unfortunately, sometimes, inevitably, you will damage a circuit board, and I was doing a lot of desoldering and putting in a lot of sockets on a board, and I was kind of getting in a hurry, and I got a little sloppy, and didn't clean out my desoldering iron. It wasn't suctioning very well, and I ended up damaging a board. So this is an example here of what a damaged trace looks like. You can see this one right here. The contact here where the pin goes lifted off, and this trace connecting these two points on the board lifted off. You see the shadow here where it's lifted off the board. So that's the kind of damage you can do when the solder sticks to the pin and you lift the chip out and the trace comes along with it. What I did was soldered in what's called a bodge wire on the bottom to connect those two pins on the bottom side of the board to make sure they had contact before I put a socket in there. And you can see how sloppy I'm showing you some of my messy work. You can see how sloppy I was. Some of these pins still have solder in them. So what happened was my desoldering iron was not suctioning very well because I had not cleaned it out soon enough. So that's why it looks sloppy. So that's what I mean about take your time, have good equipment, and use them properly, and you'll do good work. So here's some RAM chips that I pulled off in an Atari 800XL. This is a brand of RAM called Micron Technologies, MT. They made really, really cheap parts, and you find these in Commodore and Atari from the early 80s and some other computers. If you see those, pull them out, because they're gonna go, if they're not bad, they're gonna go bad soon, and they very often are bad. So this is I pulled all those MT RAM chips out of this Atari and soldered in sockets, and then put in brand new RAM, not new, but new old stock RAM chips. And sockets are great because now anytime a RAM chip goes out, I can pop it out and put in a new one. Another thing that's popular to do is to add heat sinks. Some chips get hot just naturally, especially in the Commodore 64. Some of the VIC-2 chip and I think the SID chip get a higher voltage, and they get pretty warm. And over time, that if you run it a lot, that heat can degrade the quality of the chip and eventually cause a short or cause it to fail. So these are, I buy these are made for the ARM chip on the Raspberry Pis. You can buy these for about 10 cents, 20 cents each. So I buy these, 20 or 50 at a time, and then just pop them on. This is the VIC-2 video chip on the Commodore 64. I just pop them on. They come with heat conductive tape, so you can just stick them right on. So they're inexpensive and they can prolong the life of these chips. Okay, let's move on to recapping. So computers from the 1970s and 80s, the capacitors that were made at that time, the electrolytic capacitors, are pretty reliable. They don't fail very often. In fact, I've only seen one on my systems on an Atari that failed, and it wasn't leaking, it was just discolored, but it was interfering with the sound circuit on there, and I had to replace it. That's the only one I've ever replaced on a 1980s computer. But the 1990s, they decided, well, computers are disposable, you're going to buy a new one in 2 years or 3 years, and they just started putting in crap parts. So the electrolytic capacitors on the 1990s computers always leak. And they leak nasty stuff, boric acid and other things onto your board. And so if you buy, let's say that this is a Macintosh LC and a Mac Classic, if you buy one of these, 999 times out of 1,000, probably 1,000 times out of 1,000, they're going to have leaked capacitors. And if those juices have been sitting there for years and years and years and years, the acid can eat away at the components and the circuit board, the traces, and do damage. So you want to get that cleaned up. So this was a whole another thing I had to learn how to do, was to recap these old computers, because I had a couple Macs in my collection. So this is what it looks like. This is a Mac LC I actually got from Jay, who's here in the audience. Thank you. Thank you for that mess you gave me.
Aren't they all a mess, though?
They are. They're all a mess. It's not your fault. Yes. So this is what it looked like. These are the surface mount electrolytic capacitors on these. All these 1990s Macs have these things. And you can see this brown gunk. This is the acid and nastiness that's leaked. All of them leaked, every one of them. This is what it looks like here. So you got to get those the first step is to get those capacitors off. You can use a hot air gun to do that, like I showed earlier with the chips. Some people use that method, or some people just use a soldering iron to heat up the ends and pull them off. I personally use the twist-off method. You just take a pair of needle nose pliers and you apply a little gentle downward pressure, and you just twist slightly, and the acid has corroded the legs on those things and they just break off. And that's an easy way to get them off. And whereas if you use hot air, you run the risk of damaging some of the local, the plastic pieces or other components around. So that's the way I do it. There's a lot of controversy in the field about the best way to remove these things, and people fight endlessly about it, but that's what works for me. So you get the capacitors off. The problem is, what you don't want to do is remove one of these solder pads. That's what you're trying to avoid. And so if you just try to pull them off, the solder pad will come right up, and then you have to do a repair. But the twist-off method works really well, and I've recapped about 3 machines now, and I haven't damaged any solder pads using that method.
With the twist-off method, are you able to cleanly remove the capacitors, or you still have to desolder the legs?
The legs are still stuck to the solder pad. So yeah, so what I do is I take my solder iron after the capacitor's off. I take my soldering iron and I just melt the solder, and the little pin will just stick to your soldering iron, and you just clean it off. Well, the pin, I don't think you want the pin. The pin will probably gum that thing up. So you want to use your soldering iron. You just take it off. It sticks to this, comes right off, and then you clean the tip of your soldering iron on some metal or something. And so that's the way I did that. The second thing, once you get those off, then you want to clean up all that gunk, all that mess. And so I use a warm, soapy bath. I pull any socketed ICs or RAM out of the board, and then put in a soapy bath. I take a toothbrush and I just scrub it. Some people use vinegar, which I don't understand, because vinegar is an acid, so why would you combat acid with acid? That makes no sense to me. But so I use soapy water because soap is a base, so it should neutralize the acid to some extent. So I just take a toothbrush and scrub it. Some people even put them in a dishwasher. If your spouse will let you use the dishwasher to clean boric acid off your board, then that's probably a good way to do it. It's easy, but
Vinegar will take the oxide off.
what?
Vinegar will take the oxide
Vinegar takes the oxides off, yeah. I use alcohol for that. I think it works just as well, but I haven't had a problem with that. But he's saying vinegar takes the oxides off, which is probably why people use it. So I soap it up, scrub it, and then use 99% isopropyl alcohol to do a final scrub to get any residual stuff off. I think that, in my experience, that removes the oxides. But some people, by oxides, he's talking about you get kind of a white, crusty. Oh, copper oxide, yeah. That hasn't been a problem for me, but yeah, something to look into. And then use alcohol, and then take, step 3 here is to take a solder wick, copper braid, and you just put that between the solder pad and your soldering iron. You just gently move it back and forth, and that sucks up any residual solder. And clean again with 99% alcohol, and you can see how nice and shiny clean the solder pads are when I was done with this. Yeah.
So 2 comments on the vinegar. Batteries are alkaline, not acidic, so the vinegar will neutralize the...
On the battery acid, yeah.
Yeah, so you use that and then wash it down with whatever alcohol. I use WD-40 sometimes. But my question is on the brown stuff there, after you remove the capacitor, do you clean the board before you try to desolder? Is there any issue with the fumes from all that junk when you're trying to desolder?
I don't think there's an issue, but if you apply a soldering iron to that gunk, it smells awful. It will fill your house with a nasty, nasty smell. So I try to do a clean first before I use the soldering iron. But that's a good point about the battery. I didn't put that in my talk, but thanks for mentioning that. A lot of these old computers, especially these Macs, have batteries in them, and those batteries sometimes leak and create quite a mess. Vinegar will counteract that. Yeah, you might need vinegar to clean up the battery leakage. So definitely, if you have an old Mac sitting at home, pull it apart, get the battery out off the circuit board, because it will leak and it will do a lot of damage.
Oh, the Amiga 500, that's a clock battery?
Yeah.
It's known to...
Yeah, a lot of these 1990s computers have batteries, and because that preserves the RAM, with the graphical OSs, all the settings, the resolution and colors and stuff, the battery's there to preserve that in RAM so that it's there next time you boot up the computer. But yeah, get them out of the closet, get those batteries out of there. I was fortunate, my Macs all had batteries that had not leaked, but I pulled them out, I put new batteries in there. And even if you put a new battery in there, you probably want to check it annually and make sure it's not leaking. Because you've seen the alkaline batteries, the like D-size batteries or whatever, in flashlights that leak. So it's a problem. You got to keep an eye on it. There was another question over here.
When you're using solder wick, you use gel flux.
Yeah, I don't use flux personally. I haven't felt like I need it, but some people swear by it. Flux basically helps the solder flow better, and so I would definitely look up how to use flux and see if you want to work that into your methodology. Huh? Yeah.
Electronics.
Oh, yeah, I see it too.
Replacing parts like that.
Yeah, and they just like dump that stuff on the board. I find it kind of messy, and I haven't needed it. I mean, I use a type of solder that has flux built in, a core, the flux core, and that works well. I don't know, Jay, you do a lot of this. What do you think? Flux or no flux?
I like flux.
You like flux?
It depends on what I'm working on though, too. I mean, for the most part, I'd say probably 70% of the time I don't use flux, but there is times that I do use flux. Like the smaller stuff, when you're doing electrolytics like that, I'd probably say use flux, because then you can position them a little easier too.
Yeah.
But I also like that too. I would recommend highly getting a soldering vent, just so you get those fumes away from you. So don't be breathing that stuff in. I've known plenty of old timers that'll tell you they wish they had not breathe that stuff in for as long as they did.
Yeah, thanks for mentioning that. I forgot to point that out in my tools photo, but I do use a device that sucks the air through a carbon filter. I have one right on my bench that I position kind of right above where I'm soldering, and it sucks some of that in and cleans it. And then I have a HEPA, powerful HEPA filter with a carbon filter in my room that recirculates the air. So, and if you have an open window, that helps too, to, you know, with a fan that's circulating fresh air through. So yeah, you don't want to breathe in too much of this stuff.
What kind of solder do you use when you're reworking? Is it lead or lead-free?
I use leaded, but I think it's easier to work with. But I understand why people want to use non-leaded solder, and I think that's a reasonable thing to do. But I think people who do this regularly don't like the unleaded. But
I use flux with the unleaded and flux with the unleaded. So
yeah,
if you want to use the unleaded, I suggest flux. That'll help a lot.
Good point.
You need a higher melting temperature to get the unleaded to get on the board, and
Right.
the flux helps with that.
Yeah, thanks for that tip. Yeah, I'm with anybody who wants to use unleaded solder. There are good reasons to do that. It's definitely healthier and better for the environment and better for your lungs. Any other questions? Recapping, it's scary. The first time I did this, I watched a lot of videos and really thought about it and kind of planned out how I was going to do this, and it went fine. So you got to have the right tools, watch a lot of videos. I'll mention some of my favorite YouTubers at the end of the talk, and think it through, have a plan, and it'll probably go okay. And once you do it once, then the second one I did, took about half as much time.
So there are several places to recap. The reason they're failing, somebody stole the formula for the insulating material, and they took it to China, and they copied it down wrong. So there's a period of time, which I don't know off the top of my head, that a lot of devices in that time that use electrolytic capacitors, they use those because they were less expensive.
That's I don't know if everybody heard that, but he said that somebody stole the recipe for the filters and the insulation and the capacitors, the fluid, and took it to China and copied the recipe down wrong, and so they started making capacitors that were not quite right, and those ended up being used. That's an interesting story. I didn't know that. Yeah, no, that's great.
I have a quick question. Your preference on soldering iron tips, because they come in different shapes and sizes?
I just use a standard kind of small pointy tip, and that's been fine for everything I'm doing. I haven't felt like I've needed a different kind of soldering tip, but I don't know. Anybody have an opinion about soldering tips?
Depends on what you're trying to solve.
Yeah, I've seen like a dozen.
Yeah. Yeah, a larger tip will transfer more heat, so yeah. Yeah.
For recapping, what's your recommendation as far as replacement capacitors? I know some people are like, oh, you got to go tantalum. Some people different.
I think as long as they're newly made, they're probably going to last longer than we are. That's my opinion. Okay, so this is that board, that Mac LC board when I was finished with the tantalum capacitors in. One thing to note is sometimes what's printed on the circuit board about the polarity of the capacitors is wrong. And so I would do your homework before you recap a board and make sure you're working with a board that doesn't have a problem, a mistake.
Take pictures.
And take pictures.
Put them down the way that the old ones were. Yes.
Yeah, thank you for that tip. That's a good one. Take pictures before you start so you remember where things are. I do that, and I forgot to mention that. I appreciate that.
Computer capacitors, you put like a little bit of paper tape as you turn it over and then solder.
Well, these are surface mounts, so what I do is I put a little bit of solder on the solder pads, and then I hold this down with a pair of tweezers, and I heat one side and get it melted and on, and I heat the other side and get it melted on. If you use flux, it's a little easier, I think, because you can just place it in there and.
Solder paste in a hot air gun.
Yeah, that's another way to do it. Solder paste is solder in little beads, tiny beads in a paste, and you can put that on with flux and then use a hot air gun, and it'll melt the solder and it'll just stick to the pad. So that's another method. I haven't ever done that, but that's an approach you can use. But I wanted to mention I recapped a Mac LC3. And there's a capacitor down here where there is a silk screen, an error on the circuit board, and it has to be reversed. And I actually caught that after I put it in. I hadn't powered it on, but I was like double checking, and I was like, oh shit, and went back and flipped it around. So you can buy capacitors in kits. There are a couple places that sell these. I get mine from Console 5. This is that Mac LC kit, the tantalum capacitor kit that I bought. You can see I only paid $6 for that. It's not, so these are, these are pretty inexpensive, and they give you a list of the capacitors, the farad rating, the voltage rating, where they go on the circuit board. These are some I bought for all the consoles, the Super Nintendo, the Atari Jaguar, the SNES. Those are all 1990s, and they have these electrolytic capacitors in them. So this is a future project of mine. I already bought the kits, and I'm going to recap my consoles sometime in the coming weeks or months. And don't forget the power supplies. Power supplies have often through-hole electrolytics. These are from the Mac LC and the Mac LC3. This one actually didn't work. This power supply was completely dead, and I recapped both of them. And yes, every capacitor on both of these boards had leaked and were messy. And when I recapped this one, it started working again. So the damage done by the electrolytics had knocked this particular power supply out. So yes, the power supplies need to be recapped too.
Very dangerous to do on certain power supply. I mean, you want to leave it there for it to kind of. Yeah,
for these 1990s computers, the capacitors hold more voltage, and so you want to be careful not to electrocute yourself. And so it's good to not power it on right before you work on it. Make sure it's been sitting for a few days. And there are ways. I'm not going to tell you how to do it because I don't want to be liable for that. But you can look up methods for eliminating the charge of the capacitors, and also the CRTs. Be careful with the CRTs, like in the Mac and the classic Macs, because those can hold a high voltage if they have been plugged in recently, and there are ways to discharge that before you use it. But they can deliver up to 1,000 volts to you, and can be pretty painful, or they say it can even kill you if the voltage goes, if you're touching a ground, if it goes through your heart and out your other arm, it could hurt your heart. So be careful. All right, modifications. I'll finish on this. It's really fun. It's a fun time to be working in retro computing because there are just a bazillion, as you've seen at the show here, there are a bazillion modern devices and upgrades and modifications you can do on these old systems, that video and better RAM and faster processors and all kinds of stuff, SD card devices that you can do. So I'll just show you a couple quick ones. There are a lot of modern replacements that use FPGAs, for example. This is one. I replaced a bad VIC-2 video chip in a Commodore with this VIC-2 Kawari. This is a nice solution. These cost about $100, so they're not cheap, but boy, they do a great job. And there's a $150 version that has an HDMI port. It's a little bigger. And you can get HDMI right off the Commodore, just directly from the video chip, which is super, super nice.
I think it also toggles between NTSC and
Yeah, a lot of these are programmable, so you can pull up menu and you can go through a whole bunch of different options. And
they'll actually automatically switch them.
Yeah.
So it will run everything, all the demos from Europe.
If you didn't hear him, he said these switch automatically between PAL and NTSC, the different standards. So that's a really nice feature of these. This is a Pico. There are a lot of Raspberry Pi Pico solutions now this is a replacement for the SID chip, the sound chip in the Commodore 64, which is hard to find, and they run upwards of $100 to replace. This Pico-based SID chip you can buy it assembled for about $30 off eBay or other sellers. So it's an inexpensive replacement. It's not quite as good. The SID has some analog components in it that gives it kind of that rich distortion sound. So the sound won't be quite the same if you're an audiophile, but if you just want to play games, it's great. Here's a board. So here's a board with a video replacement, the SID chip replacement, and a PLA replacement. The PLA is the chip that kind of orchestrates the The chips all playing nice with each other on the Commodore 64 board. This is a really inexpensive, like $20. You can make one of these. You can buy the pieces and make this yourself. These are GAL chips that aren't made anymore, but they were used in a whole bunch of things, so they're widely available, and you can program them, put them in this special adapter and plug it into a socket, and now you have a replacement PLA. And the PLA, by the way, on the Commodore 64 is one of the most common points of failure when you boot up and have a black screen or something's wrong. And then there are CPU accelerators as an example. I have the Amiga out here at my exhibit. This is called a PyStorm. This is a CPU replacement. You take the 68,000 CPU off the board, plug the PyStorm in, put a Raspberry Pi. This is a Pi 3A Plus on top as a hat. And the Pi, through the PyStorm, is emulating the CPU. And you can set it to be different CPUs. So you could do a stock 68,000, you could do a 020, 030, 040, et cetera. And it runs super fast. The Pi provides memory to the system that can be used as well. Let me show the next slide here. You can also boot, for the Amiga in particular, you can get modern OSs that are designed specifically for the Amiga that run on the Pi and that allow you to interact with the Amiga. So I have this running on my exhibit. I'll show it to you. But you can launch games. The games launch on the hardware. And so what's shown here is this image is coming from the Raspberry Pi through an HDMI cable out of the Amiga. And then the other image is a game running on the hardware, on the emulated CPU, but everything else is the original hardware out through the RGB port, upscaled to HDMI. So this just opens a lot of doors. This thing is crazy cool. There's web browsers and all kinds of stuff built in here. Emulators. I can show you if you want. You can actually emulate a Macintosh running on the Raspberry Pi inside the Amiga. It's crazy. It really messes with your head. All right, I'll end. I think we're out of time. Most importantly, have fun. Working on old computers can be incredibly frustrating, but try to remember to have fun. Take your time. It's easy to make mistakes, and I've made a lot of mistakes. Invest in good hardware and supplies. I really believe in that. They are expensive, but if you do a lot of this, it's well worth it. YouTube is your friend. I learned everything I know how to do from YouTube and asking some of you questions that I know. Build a community. It's good to know people in the community who you can ask questions and bounce ideas off of. That's why we're here, right, to build community. Make mistakes, learn from them. Mind your health. We talked about that. Some of this stuff can be dangerous. Share your projects and teach others. If you learn a skill, teach others how to do it and spread the happiness. Have a budget. I struggle with this because, a lot of these things are expensive. There's just so many cool gadgets coming out, and I want all of them, and I have to pace myself. It's like, all right, I'm going to spend $200 this month, and so you can't have it all. And clean your desoldering gun regularly. Man, I learned that lesson the hard way. I learned from YouTubers. I love Adrian's Digital Basement. He's incredibly popular. You can see he has 223,000 subscribers and over 500 videos. He's a lot of fun, and I've learned a lot from him. I like the Retro channel as well. He's an Australian guy that has a lot of repair videos. And Jan Beta's been around a long time doing this, and he's also a great YouTuber. So thank you to all of the YouTubers who I've learned an amazing amount from. And I put a copy of this on my own YouTube channel, which is, I don't have much there, so don't expect much. But this, I did record this, and it is there at Atari Projects on YouTube if you want to watch it again. And I think they're recording it as well. So this exact presentation will be available through VCF. And that's my email address, so I'd love to hear from you. Reach out anytime if you want to criticize what I've told you. If you have some countering opinions, I would love to hear that, because I'm still learning. I don't consider myself an expert, but I have taken a deep dive into this, and I feel like I've learned a lot. So feel free to share your wisdom with me and give me some pointers. And if you have questions, I'm happy to answer questions as well. So thank you very much.